This meeting is being recorded.
Welcome, guys. So this lesson is going to be starting off doing Module B Week 2. I'll put that on the screen because it's not there already. If you're not up to Module B Week 2, I suggest download the submission sheet and you can start it today because it is very, very achievable. Our learning intentions for today is we're going to be able to apply the distributive law. I won't focus too much on the name, but we're just going to be using some multiplication problem solving skills. We're going to look at drawing angles, and we're going to be identifying lines and rotational symmetries. Okay, so our success criteria for today, we should be doing some multiplication problems. We're going to draw some angles, and we're going to draw some images of figures. No, you didn't. Hi, Isaac, how are you going? Okay, so guys, we've been doing our make number easy strategy. I want you to have a go at doing these. CPJ, turn my camera off. Oh. No, I think I want my camera on. I want you to have a go at the following. So when you've had a go, and you've solved it and you're confident with the answer, I don't want you to put the answer into the chat box. I just want you to put an S. So looking at A when you've solved it. And then we'll talk through some of the strategies. All right, guys, we're focusing on the question. So we're looking at A, 4 times 6 times 5. When you've solved it, just put an S. Don't put the answer in. So we've got 2 people who've solved it. We've got 13 people in the class. I think we need some more. We've got some more S's. Okay, so all of those S's, tell me what your strategy is. What did we do? What numbers did we multiply first? 4 times 6 times 5. Yep. So CPJ did 4 times 5. Did anybody else do 4 times 5? So she grouped the 4. Yeah. So she grouped up the 4 and the 5. So we got to 20. And then they multiplied that by 6. So if we just do 2 times 6. Yeah, definitely watch those signs. So 20 times 6 gives us, guys, or 2 times 6, what does that give us, guys? Yep, 120, 12. Multiplied that by 10 and we get 120. Awesome. All right, I want you to have a go at number B. And when you've done it, I don't want you to put the answer into the chat. I just want you to put in what you think it is, but just an S for solved. Yes, this is a start. We're just warming up, okay? So we've got 14 people. We're doing number B at the moment. We've got lots of S's. Thank you, Vincent. And it was great to see you, Vincent and Isaac. Okay, we've got some S's. What numbers did we add up first and why? I'm going to change my colors. Pointer, I'll change it to a nice purple. So CP Jane added, and Isaac added 77 and 23. Yep, so did Lexi. All right, so if we add 77 and 23, what do we get? Oh, because we get 100. Thank you, Isaac. We definitely get 100. So we've got 100. And then we're adding 73 onto that, which gives us what, guys? 173. Cool. All right, we'll do one more. Should we do C or D before we move on, guys? We'll give an option. C or D? So got lots of C's. All right, we'll do C's. All right, and I'll just cross out the D. I want you to have a go at doing C. If you've solved it, put an S into the chat box. So don't put in the answer, guys. Just put in an S. Ornella, if you've solved it, put in a S. Or you could double check it for us on the calculator, Ornella. I just put in an S. Brilliant. Okay, so what was our strategy that we used? It's a capital, that's okay. Oh, we write an S because it's solved. All right, guys, what strategies did we use to solve number C? 5 times 4, so because that's the easiest one. We'll grab the 5 and the 4. 5 times 4, guys, what does it give us? Okay, 20. And then we need to multiply this now by 14. All right. It's 2020. Settle down, Isaac. Okay, so what is 2 times 14, guys? Oh, thank you. Oh, I like this. Like your thinking. So I think it's Cooper did 14 times 2 times 10. I really like that. So 14 times 2 gives us 28. And 28 multiplied by 10 gives us what, guys? 280. All right, we're pretty good at this. All right, I want you to tell me how you would solve the following. 7 times 22. By the way, I've not seen this movie at all. I would do 7 times 22. It's the worst in the world. Oh, that's okay. Isaac, we don't have to like every movie. But 7 times 22. So someone would do 7 by 22. Does anybody have... So AMCF would do 7 times 20. Frozen 2 made you cry. Yeah. Oh, I don't think you got forced. All right, we're getting back on travel. Oh, that's really cool. 140 plus 7 times 2. All right. I like that strategy. I'll put it down. So, oh no, we've gone too fast. So AM did 7 times 20 plus 2 times 7. All right. We'll do the easiest part of this problem first. What is 2 times 7, guys? 2 times 7, quickly, quickly, quickly. We've got 14, brilliant. And the next one is 7 times 20. What would that be? 140. Brilliant. So guys, what is 140 plus 14? What do we get? Awesome, we get 154. So what we've done is we've used a distributive property. So we've broken the number down into smaller parts. So 16, we can break it down into 10 plus 6. And we can multiply each of these parts by 4. Okay, so 4 multiplied by 10 plus 6 multiplied by 4 should give us the answer. Guys, 4 multiplied by 10, what does that give us this? Or we can double and double again. That's also a really good strategy too. So we get 40 plus 6 by 4. What do we get, guys? I got lots of 64s. My question was, what was 6 times 4? 24? Like, I think you're one step ahead of me. And we're doing this for the recording. So finally, 40 plus 24 gives us 64. Brilliant. Okay, we'll have some more practice. I want you to have a go at doing this problem in the by yourselves, but do not put the answer into the chat. Just put an S when you've solved it. And Ornella, if I could get you to do this on the calculator just to make sure that we're okay. So have a go with this one. Don't put the answer into the chat. Just put an S when you've solved it. Oh, that's okay, Vincent. Yes, I can see it. Awesome. So what strategies did we use in the chat? Let me know. Tell me how to solve it. So these people have solved it. Tell me what your thinking was. How did you do it? Yep. So you've broken down the 13 into 10 and 3. And you've multiplied it by 3. Cool. And then we've just done it in parts. So you did 3 times 10 plus 3 by 3. And we got, Vincent's already put the answer in. So they've got 30 plus 9. And we get 39. I think we're good with this strategy. I'm really happy. We'll do another one and then we'll get forward. We'll get going. So 6 by 61. When you've solved it, I want you to put an S. And I will get to it. Isaac, I'm happy to answer your question if it's related to the work. I don't know. That doesn't actually relate to the work, and I don't want to see too many emojis. So when you've solved it, oh, Nella's solved it. Awesome. We've got some S's. Brilliant. So how did we do this in the chats, guys?
Are you missing my dulcet tones there, Cooper? I'm here.
Yeah, I think I'm missing your tones as well to carry.
Oh, I was saying before, an interesting little strategy about multiplying by 3 is to double it and add another one.
Oh, that is a cool little strategy.
It's a cool little strategy.
I didn't even think of that.
All right, I'll keep it on.
Okay. So we've got some solutions. What's our strategy, guys?
Interesting. It looks like Angus has done 61 times 5 because that's another interesting strategy. You can do 61 times 5 and then add another one.
You could definitely do that, yeah.
It's still quite tricky.
I don't know how I would do it. I would do 6 times 6 gives me
Why can't I just do it the
36
normal
multiplied
way?
by 10.
What's the normal way?
There's lots of different ways to get this answer. Yeah, that's really cool, Vincent. So 6 times 60 gives us 860 plus 6 gives us 366. Yes, you can annotate, Kerry.
Yeah, I mean, most kids will probably just set it up seriously. They'll do it like that because that's how they've been taught to do multiplication. Yeah?
Yeah.
So 1 6 is 6, 6 6 is a 36, bingo, bango. So I suppose what you're looking at here is whether you want to do other strategies. I mean, you might have doubled it, doubled that, and so you get 122, and then times that by 3. Because if we double it and times it by 3, it's the same as multiplying by 6. So we're just looking at strategies for in your... Whoa, whoa, it's all gone crazy there.
It did.
Lost the screen.
Yeah, we just lost your... That's a cool little strategy as well. Yeah. So you... Yeah.
I didn't realise you had rights there, Isaac. So Isaac hijacked your...
That's okay. Can we
screen.
still see my screen?
No, we see you.
Oh, you see me.
Hi.
Hey, I'll see if I can fix it up. There we go. Got my screen back.
No,
Sorry, guys.
no. We still see you.
You still see me? I got 2. Sure. Can you see my screen, guys? Let me know.
Now you're back. Now you're back.
Now I'm back. Now I've lost everybody's comments. Ah,
That's all right.
I got him back. Yes. Okay.
So Isaac, whatever you just did, don't do it again.
Do not do it again. But I do like Kerry's strategy. So Kerry just multiplied 61 by 2, which we got, guys. 61 multiplied by 2. 122. And then she just multiplied 122 by 3, which gives us 366.
Mm.
So that's a cool little strategy. And we can do the bracket strategy that I've been doing. So 6 multiplied by 60 plus 1. And this was Vincent's strategy as well. So 6 times 60 gave us...
Just answering Vincent's question there, why do we multiply it by 3? Because we doubled it. So we multiplied it by 2, and then we multiplied by 3. So anything times by 6, you can just double it and multiply by 3.
All right. So, and we get 366. So like we're saying, there's lots of different ways we can get to that right answer. Or we can use a calculator as well. But we do want to be doing our mental arithmetic at times. Okay, so we're going to be doing some drawing angles. And this relates to the worksheet. Don't think I'm going to spend too long on this. What I usually do is I start with an T as a reference angle, so this would be 90 degrees. Then I put my protractor on and I find 100 degrees. So we're going around on our protractor. So we got start at 0, remember? Going around, we get to 100. There we go. Or I'll make a line right here. And then we connect that line to the origin or the 0. But we use a ruler. Kerry, did you want to say anything on drawing angles?
No, just that they've got to have the protractor lined up. They can be a little bit haphazard. They've got to make sure that it's horizontal across.
You do. So like a really good strategy is to just draw a T and then measure the angle in the T.
Yep. Can I just ask who user is up here, please? This user has their mic on, and when you're actually coming into the class, we need you to use your names because we actually like to know who's there. And so I don't know who user is.
Okay.
Yep.
Lastly,
Who are you?
That's okay, user. What's the name of this angle, by the way, guys? Just getting back on track. Oh, it's Felicity.
Felicity.
You're one of my
Thanks,
students,
Felicity.
Hey. Okay, so the angle name, guys, what is it?
The angle name from the other day. Remember, we have different types. Yep.
Yep, it's an obtuse.
Almost. Obtuse. Yep.
All right.
And
obtuse
see that
angle.
Oak's in the room. Hello. Hi, Oak.
All right, we'll move on. We won't do too much of
Maddie.
drawing angles. Okay, so last week we looked at obtuse and obtuse. So obtuse, guys, remember it was from, but not including 90 to 180. So any angle greater than 90, but less than 180 was obtuse, and acute was up to 90. Was up to 90. 90. And my question is, how many degrees are there in a, that's okay, Isaac. How many degrees are there in a circle? We're just doing some revising at the start. 360 degrees. So we're just going to be focusing on reflex angles. So they're less than 360, but greater than 180. All right, so this is the angle we care about. We don't care about this angle. Or this is the angle we want to know. but we do care about that one. My bad. All right. So guys, because some of you don't have 360 protractors, can I get in the chat who has a 360 protractor? Oh, look, Lexi has. Oh, you got something easy. Cooper does. Yeah. So a lot of you have the 180 protractors, and this is what we're going to be using. So to work out the reflex angle, we're going to work out the inside angle, or this little angle. And what do you think the little angle is, guys? If you want to guesstimate it in the chat, the little angle, let me know if you're confused by a question mark. It's definitely not 450. Some people said 45. We'll measure it. So remember, we start at 0. Then we go around. Yep, and we get to 45 degrees. Whoever said 45 are amazing. Yep.
Watching you do that then, I would have automatically put my protractor on the horizontal. Always.
I probably
See
would
how
have
you've
done
got
that
it-
too. Yeah.
Yeah. I'm just wondering,
Um,
I would have lined it up in the middle. It looks awkward to me to do it that way.
yeah, it does to me as well, Carrie.
So that's not you doing that. That was what was on the slide. Is that right?
That was probably me doing it a long time ago and
Oh,
thinking it was
okay.
a good idea and not fixing it up.
Yeah, I try
Okay.
and do it on the horizontal.
All right,
I'll
so
put that.
45 degrees. So we just minus that 45 from 360. What do we get, guys?
Isaac, can you just stop? Just stop. It's just distracting.
60
Thank
minus 45. This will give us our reflex angle. So, 315. 315. And remember, we're going to put our degrees. So, include the degrees there. We'll do one more. So, I want you to guess what the angle is first. So, we haven't worked it out. That's okay. What do we think this angle is? In the chat. So we're guessing this angle right here.
Well, I can see that it's greater than straight line, so it's got to be more than 180.
It does.
And that will make it a reflex angle because it's more than 180. And so Angus has suggested maybe 215. Doesn't look unreasonable.
So we'll put Angus as 215. Yeah, it could be 215. Jacob, what would you say the angle is? Jacob says 210.
210.
Ornella, what would you say? We're just guessing, so we could be wrong.
Kai's had a go at 225.
Yeah.
And Isaac,
Isaac 211.13. All right, let's measure it. So remember, we can only find out the little angle, and this time we're aligned with the horizontal. We start at 0, go around, and we get to 150. So that little angle right here is 150 degrees. And we're minusing that from 360. Remember, so 360 minus 150. What do we get in the chat? Yeah, we get 210 degrees. 210 degrees. Am I going for time? We have 5 more minutes. So what we could do at the moment is from this week's work from lesson 1, we can do angles of revolutions. I'm going to do some reflections very, very quickly, and then I'll let you go. Okay? So with the reflection work, reflections are really important in maths. And you've probably all done this in primary school. So in the chat, let me know if you've done reflections in primary school. Just put a Y. Awesome. What do we know about reflections? So this is the object. This is the image. So the image, does it have the same size? Yes. They reflect things back. Awesome. But the image? Or you probably have done this with the mirror. So the image, same except, so it's the same. What do we mean by the same? It is the same size, yeah? Yep, same size. Brilliant. So the angles inside the image, would they be the same, guys? Same inside angles or internal angles? Angles. I like the different places. So with the reflection, it'd be the same distance behind the mirror line, or so it'd be the same, yeah, it's been flipped. But it'd also be the same distance behind the mirror line. Behind the mirror line. A math word that we use and you'll be looking at next year is congruent. Let's go back. It just means it's identical in every way. So same angles, same distance behind, and same size. All right. You'll probably come up with this in science. So the object that's reflected, we've referred to as an image. If this object is 5 centimeters in front of the mirror, how far would the image be? That's okay. It's just revision, and we've got 3 minutes. That means you'll be an expert. So the object is 5 centimeters behind the mirror, in front of the mirror. The image, or what we see, is how far behind the mirror, guys? Yeah, maths and science definitely overlap. So if you see yourself and you're 5 centimeters in front of the mirror, the image, or what you see, it would be 5 centimeters behind. So it needs to be the same distance, as well as the same size. Okay, so this is from your worksheet. And point 2, how far is that from the line of symmetry? So the mirror line is basically a line of symmetry. Point 2, how far is that from the line of symmetry? 6. We're just assuming that it's centimeters. I'm not sure if it is, but it's 6 squares. We'll double check it. So we've got 1, 2, 3, 4, 5, 6. So it'll be 6. So if we need to reflect it, we need to measure out 6 squares. So we've got 1, 2, 3, 4, 5, 6. And to be really, really symmetrical, I don't think it is millimeters. It'd be a bit too small for that. They are squared. It's just, I'm not sure if they're actual centimeters squared. That would be, the image that we're reflecting would be like here and here. Harry and I would like you to see you using a ruler to draw this, okay? Because you want it to look identical. Okay. We say this image is bilateral because it only has one axis of symmetry. The butterfly, that's its axes of symmetry. Can we think of some objects? Is it Spanish? I think bilateral is Latin. Can we think of any other things that have bilateral axes of symmetry, or only one axis of symmetry? In the chat. Oh, that's okay. We got a snake, brilliant. A human, awesome. And we've got a human. And how am I going for time? I think I've just gotten to the end. The other type of symmetry we have is radial symmetry. So multiple sections can be rotated. We're at the end of the lesson, guys. Yep. An apple definitely has radial symmetry. I would really like you to have a go at doing, because we only have one day of this week. Go back.
No, Cooper.
To be doing lesson 1 of B2. We're going to hopefully continue doing B2 when we come back. Yes, we're done.
Okay, so yeah, I probably, for those, some people came late. So I think this is the last lesson for the week. Nothing's
is.
running. Yeah, nothing's running Tuesday to Friday, and we're not sure what's happening after the holidays. So those people who normally come to my support class on Tuesday, it's not happening.
It's not happening.
No.
However, guys, even if you're at the support class, you can do the reflections.
Have a go at everything. Yeah, and they can
Go at
ask me.
everything.
You can still email me. All right, so email me. I would have set you some reduced mathematics tasks, and yeah, we'll do some planning over the next 4 days and see how we're going to work this out.
Yeah. Ornella, I would really like to see your reflections, so please have a go at that. If you have any questions, please just chuck it to us in the chat.
Your holidays start tomorrow, right?
They start tomorrow. Yeah, it was decided last night by the Victorian government. That's okay. Felicity?
That's all right, Felicity. Yep. I don't know whether you can
I'll
change it
see if I
next
can-
time, though, so that we can always see who you are.
Yeah, Felicity, do you play tennis because Mila plays tennis?
I'm going to have to say goodbye because I've got other things on.
Yeah. Oh,
So,
I do.
cheerio,
All right, bye,
everybody.
guys.